Hello everyone and welcome back to another classes video. This is going to be your project video for classes, and this is probably going to be your last project video in the main segment of Python. There are going to be advanced Python videos most probably that are not going to be part of this, basic Python course. And of course there's going to be a competitive programming course where we teach you, how the memory works, how CPU works, how you can optimize your code. But this is it. This is going to be your big project. We're going to be making a Monster Legends / Dragon City type game. So what this means is it's actually more like Pokemon, you could think of it, right? You might know that if you don't know Monster Legends. But basically this is a game where you collect monsters. These monsters have different descriptions, different attributes, different styles of fighting. And there's different things you can do. You can send your monsters out on expeditions. You can make them battle with each other. That's what we're going to be doing. And the way we're going to be doing that is we're going to have a class, a parent class called monster, and then subclasses like a goblin or a dragon or a mermaid or something like that. So let's get right into it. There's going to be a lot of checkpoints, so make sure you understand all of them. And of course, I'll link the source code in the description. This is a pretty big project, and I want you to add on to it. You don't have to copy everything that I'm doing. You can just go to the source code and copy paste what I have right now for you. Okay, so let's get started. Okay, so before we take a look at our main control functions, let's talk about this. Okay, so this is kind of obvious. We're probably going to be using this on most projects. Our global variables are gold and our monster list, so what monsters we have. And then our complete monster list is basically every single type of monster possible to collect in this game. In this video, I'm only going to be doing 2 monsters, which is actually very little, but I want you guys to use your creativity to make new monsters with different types of, attributes. Now, for our main control functions, of course, we have a backstory and we have a start, and we call them simultaneously like this. The backstory function is a bit different, okay? So before we even, print out, welcome monster trainer or backstory, we actually have to give our player a monster, because if they have no monsters, how will they, send our monsters to expeditions? How will we battle with monsters? What do we even do, right? So we're gonna give them a starter monster similar to how we get a starter Pokemon. Okay, so we're gonna take a random monster from our complete monster list, and we're going to append it to our monster list. And then we're going to say this: welcome monster trainer, your goal is to create the best monster museum the world has ever seen. You will start off with a, and that's the starter.name. So remember, this is a object. A monster is an object, and it will have a property called name. So like, let's say a goblin, right? The goblin is its name. We're going to just fill it in right here. Now we have our start function. It's very important that you understand what a start function does. This is like our control center. This is where we can come back to after we finished actions, right? Like after we finish an expedition, we can run this code again. After we battle, we can run this code again, and so on. So let's see what we have. First, we're going to check to see if all of our monsters have died. Now that's kind of morbid, right? But basically, you can lose your monsters in expeditions. If you have no monsters, you can't send your monsters out into expeditions. There's no way you can get a monster, so you lose the game. That's the first thing we have to check for. Then we have an input. You are in your monster museum. You can send one of your monsters, have 2 monsters battle each other, print a description of the monster, and leave your monster museum in the hands of the government. That's a little small joke I added there. But anyways, these are different things you can do. So let me explain them conceptually before we move on. An expedition, as said in like line 28, is basically where you send your monsters to explore. You might get gold, you might lose your monster, but you also might gain a new friend. And this is the main way of you gaining monsters. Then battling. I'm not going to get into the details of battling because we already have a video on that, like how monsters fight. I think in the third video of the text adventure game, the for loops unit. So go watch that and you'll learn how to simulate a battle. So right now I'm just going to be doing a coin toss, two monsters battle, 50% chance that either one wins. But later on you can use the attack and you can use the health and make a sort of a simulation. And you can even add, unique attacks for each subclass. Like for example, a goblin has a unique attack compared to a dragon, right? Then of course, description prints out a description of the monster. So basically, we're going to probably ask, like which monster do you want a description of, and then put the description. And then exit is where you exit the game. And of course, we have our recursive function right here. Okay, so let's first look at description because description is probably the easiest function to write or understand. Okay, so before we start, the reason why I can't run this is because right here we don't have expedition or pre-battle defined. So it might be a bit confusing, but at the end I'll go through everything step by step on how it works. Okay, so just try to understand conceptually what I'm doing. The first function, and this is really important, we're going to use this a lot, is the get monster description function, which returns a string of all our monsters in a methodical order. Okay, so what this means is we have a string right here, S, and it's empty. Then we're going to loop through our monster list and we are going to basically format it in a certain way. So we're basically going to say the number, right? So 1, 2, 3, and then we're going to say like the monster list, the monster in the monster list. For example, let's say we have a goblin as our first element of the list, right? So we're gonna, the index of the list is 0. We're going to do 0 plus 1. So 1, 1 dot. Okay, let me just try this. It'll be like this. There. Man, English is hard. But basically, that's what it's going to look like when we print it out. And we're going to print out, goblin, dragon, whatever we have inside our monster list. Okay, this is helpful because this will allow the user to see, all of their monsters. Okay? And now this description function, don't get it confused with this. This will get the description of a specific monster. It won't just list out all the monsters, but it'll get a description of a specific monster. And that's why we have to first print out all the monsters they can choose, right? And then we're going to basically run this code, okay? And I'll explain why we use try and accept in a bit. But basically what this is doing is we're going to choose a monster based on number. So let's say 1 is goblin. We're going to enter 1. Then we're going to print out the description of whichever monster we choose. So 1 minus 1 is 0. The 0th element of your monster list is a goblin. And we print out its description. But we need to check for cases. For example, let's say they don't enter a number. We have to return a value error, right? It'll return a value error, and that's why we use a try and accept. The accept, what it does is if we run into an error, instead of breaking the code, it'll run whatever's here. And basically, this is recalling the function. An index error, that's another problem we could get, is let's say they enter a huge number, and we get an out of bound, error. Like if it's way out of bounds, like then like 1000, if you only have like 2 monsters, right? Then we're gonna get an error, but we also take care of that using this exception. And that's what programmers do. They just take care of as many exceptions as they can, make sure they have a fallback plan just in case your code would crash in a certain scenario. Okay? So these two are basically pretty obvious. The next two, which is like the battling and the expedition, is a bit more complicated, but I'll make sure to explain it the best I can. Next, we have our battle functions. We can pit 2 monsters against each other and see who wins. Okay? Well, it's not that exciting because I haven't implemented a cool battling system yet. It's just a coin flip. Okay? So the pre-battle first asks the users to select 2 different monsters to battle, right? and we make them choose the index, right? Choose the first monster. First, we print the monster description, right? So like 1 goblin, 2 dragon. They choose the number, we subtract 1 from it to get the index, we choose our 2 monsters, and then we pit them against each other. And of course, we have a value error and an index error. It's basically the same logic as up here. The battle, basically, we're going to choose a winner from monster 1 and monster 2, and it's just going to be random using the choice function. And then we print out the winner of the battle and we go back to start. Now, I'm going to emphasize this again, but I do want you to come up with a better battling system than this. What I was thinking was that using classes, right, you can add an attack feature to each one of your subclasses. For example, a goblin has a different style of attacking. A dragon has a different style of attacking. So it'll go like a turn-based combat where basically the first monster uses its attack first, and the dragon uses its defense attack. Defense attack uses its defense move, right? And then the opposite. The goblin uses its defense move while the dragon attacks. And then whoever reaches 0 health first loses. Finally, let's look at the expedition. Okay, so now we're here, the expedition. So now we can choose to send a monster on an expedition. And of course, it checks for invalid conditions. It's very similar to the previous ones. We ask them to choose a number. If it's a value error or index error, we go back to expedition. But the thing that's different is we're going to call a method on the monster that we choose. So just imagine this as being the monster that we choose. We're going to call expedition results, meaning that each monster might have a different chance of bringing in, goods. For example, a goblin, in my mind, has a better chance of getting gold in monsters than, like, let's say a dragon. But a dragon has a better attack and health stat. And this is how you want to kind of balance your game. Some are good at battling, some are good at expeditions. Okay? And what this is this is basically the index, right? So the reason why I'm passing in the index here is because let's say we want to, let's say the monster dies, we need to know what index to remove our monster from. Okay, so take a moment to get this in, because now we're done with our start function. The only thing left to do, of course, is to make our monster class and their subclasses. Okay, everyone, here is our class. Wow, this is pretty big, isn't it? Well, again, let's go through this step by step. Let's read this comment. This is our true parent class, which is kind of obvious, right? All of our monsters are going to be children of the monster class. All monsters are derived from this class. Each monster must have a name, description, health, attack, gold, and luck attributes. Now let me explain my logic behind this. Name and description is kind of obvious. Health and attack are basically what's used in battles. They aren't used right now, but like I hope that you use health and attack when you're doing monster battles. And of course, I forgot to even say this, but you don't even have to use monsters, right? But monsters are the easiest thing I have in mind for this sort of collection game. Probably because I've played a lot of Monster Legends and the like. But anyways, gold is the amount of gold they bring back from an expedition if they do get gold. And luck, you'll see later, or like right now, is basically how lucky they are to get, dragons and gold. The more luck they have, the better chance they have of getting, a new monster. And the lower chance they have of dying, basically. They must also have an expedition results method, they should say. Okay, now let's take a look at our init function. Very, very simple. Name, description, health, attack, gold, luck. Make sure you always have a docstring identifying what types of variables each one of your attributes are. And then we do the self.name equals name, self.health equals health, so on. Okay. Now the expedition results is the juicy part that you've all been waiting for. How do you collect your monsters? Okay. So there's a bit of math involved in this, and you can just use my math for granted, but I'll still explain it to you. So our result is going to be equal to 5, okay, at first. The MI is basically the monster index that our monster is in our Your Monster list. And what we're going to do is we're going to choose a random number from 1 to 50, okay? So let's say the number pops up as 25. And actually, let's make this 0, because you'll see what I have in mind for the result. But anyways, right now the result is 0, and we're going to set it equal to a random integer from 1 to 50. So it could be 25, it could be 3, and we're going to multiply it by 1 plus self.luck, and remember self.luck is an integer between 1 to 100, times 0.01. So let's say their luck is insanely high, it's 100, right? So 100 times 0.01 would be 1, right? And 1 plus 1 is 2. So we're basically multiplying our chances of getting good stuff by 2. Let's say this self.luck is 1. 1 times 0.01 is like really low, like 0.01, right? So now we're only multiplying our chances of getting something good by 1%, which is not that much. And that means your monster could die, theoretically, very often if you send that monster to an expedition. Now, if the result is greater than 70, and you can play around with the numbers a bit, you get a new monster. And we're basically choosing a monster, appending it to the monster list, and printing it right here. If the result is less than 15, we lose our monster and we pop it from our Your Monster list. And then if it's neither of them, then you just gain the gold. And the gold doesn't do anything right now, but I'm hoping that in the future you might set up like some sort of shop system where you can buy monsters. And then even if you, for example, like lose all your monsters, you can still buy, monsters from the shop. I haven't set that up yet because this video is already long enough as is. Now, we've made a monster class, but how do we make a specific monster? Let's make a goblin, shall we? Here's our goblin. Goblins are very bad at combat, but have a high gold return. They also have special luck boost if you have more than 200 gold. And this is where it comes in, where I make result equal to 5. So actually, let me go up here. And let me make it plus equals, because right now it's just resetting results to this value. But I wanted to add on to this value because if our gold is greater than 200, we're going to give them a huge boost in luck. 10. We're going to add 10, which is like huge, because remember, 15, at 15 and higher, they have no chance of losing their monsters. If the result is already 10, they'll have to roll an incredibly low number, like I'm talking like 1 or 2, for their monster to be lost. So this boost of 10 is actually really good, right? So this is the attribute that I was talking about, right? Or the benefit of having a subclasses, because different monsters have different abilities in either expeditions or battles. Okay, and what I did here was I inherited the monster class, and I'm overriding the expedition results. So it's not this anymore, but it's going to be my own, the goblin's expedition results, right? And we're going to basically say if gold is greater than 200, we're going to call the super. What this means is we're going to take the parent's expedition results function, and we're going to set its result equal to 10, not 0. Else, we're just going to call our parent's expedition results as normal. Very simple, but still a very cool aspect of a goblin. Now, the final thing we have to do is add a few goblins to our complete monster list, and then we're done. Here it is. We're going to create instances of specific goblins to add to our monster list. when you start adding more monsters, you're going to start adding different types of monsters, right? Not just goblins, but dragons. Yes, I have an addiction to dragons, don't judge. But anyways, the first goblin we'll add is a giant goblin. And I didn't really, focus on the description, but please do make the description like really cool with lots of lore, and lore is basically like a story. Add a story behind this giant goblin or trickster goblin. And then these numbers are basically in order: health, attack, gold from returns, and luck. As you can see, the return of a trickster goblin is great, but it's really bad at fighting, while this is decent at fighting, but has a lower return rate and luck rate. And this is it. Now let's run our code and let's test out a few of our functions. Okay, so it's working like normal. Let's look at a description for one of our monsters. So we can choose a trickster goblin. This monster is sly and cunning. Okay, press that out. We can't battle yet because we don't have, 2 monsters. So let's send our thing out on an expedition. Okay, we have 150 gold. Oh, oops. Okay, 300 gold. I want to wait until we get a monster to see if it works. Okay, that's a lot of gold. Come on, please. I want a monster. Oh, I don't want gold. I've discovered a new giant goblin. You now have 2 monsters. Okay, now let's make them battle with each other. Trickster goblin and then giant goblin. The winner of this battle is a giant goblin. That's a coin flip. But that should make sense because giant goblins are better at combat. And let's exit. And this is our game, Monster Museum. This is the start of an amazing game that I want to see a lot of progress in. This can be considered sort of your final, along with the text adventure game. You can incorporate this within your text adventure game. I hope you guys enjoy this, and I hope you guys enjoyed Python. This is pretty much the end. After this, you guys will be exploring things on your own, making your own projects. There's lots of different things you can do. You can go and focus on competitive programming, which is very good for anyone going into the programming field or computer science field, if anyone's interested in that. We also have GUI development, where we teach you how to create your own games, like your own 2D games, not just with text, right? It'll teach you a lot of different concepts like that. You can move on to HTML. You can do Scratch, though I don't know why you do that now that you know this. I'd rather you move on to GUI. But yeah, this is it. Thanks for watching. I've enjoyed your guys' presence for the past who knows what. And I expect to see a lot of monsters. Bye.